so 10.3, we'll start with the square off to the right that says theoretical probability. So theoretically means like in theory. In theory, if I flipped a coin 10 times, how much would you theorize would be heads? 5. There's something called experimental probability, meaning I'm actually going to perform the experiment. I'm going to toss it 10 times, and it may be heads 5 times or it may be heads 3 times. It's just depending on. Most of the time, we are calculating theoretical because the thing hasn't happened yet. But there is one in the notes there where it says, here's the outcome of an experiment or data. What is the experimental probability? Then you just look at the experiment, not what you think would happen. Pretty easy to tell the difference. So let's fill out this theoretical probability of an event. It says, when all the outcomes are equally likely, the theoretical probability that event A will occur is, this is kind of new notation. It just means the probability of event A, whatever we're talking about, flipping a head, flipping a tail, whatever it is. It's just P stands for probability. Sometimes there's more specific information. Like I said, probability of flipping a tail. It might tell you more. Otherwise, it's just P of A. So to find the probability, the numerator is the number of outcomes in event A, or I like to say successes, over total outcomes. So let's put an example quick. Let's say I'm doing the probability of rolling a 5 on a standard dice. How many total outcomes are there on the dice? 6. How many of them would be a success for me? Just that one 5. There's only one 5. So your normal probability, your success is what you're looking for, what it's asking you about. How many times that will happen over the total. Theoretical probability of an event is often simply called the probability of an event. Example 1, you pick a card from a standard deck of 52 playing cards. Find the probability of picking an 8. So let's write probability. You can just put 8, or you can say picking an 8, whatever. I like to do the bottom first sometimes. The total out of the whole deck is 52 cards. How many 8s are there? 4, one of each suit. So I could draw 4 different cards and be successful. What does that simplify to? 1/13. You do have to simplify. I don't actually require you to write the P of 8 every time. Number 2, or B, I should say, find the probability of picking a red king. Probability of a red king. The total, still 52 cards to pick from. How many red kings? If you're not familiar with cards, look at them again when you go home. We did a little activity the other day. Hopefully we know. Red kings, 2. The king of hearts and the king of diamonds. What is half of 52? 1/26. Always simplify, even if it doesn't tell you. You would get taken off if we don't simplify. All right, we have a new set of information. We have 10 balls numbered 1 through 10 put in a hat. A ball is selected at random. What is the probability that it is a 7? Jesse, what do you think? 1/10. Yeah, 1/10. And I'd be okay if you just write the fraction. B, do this on your own. What is the probability that it is an odd number? Our odd numbers are 1, 3, 5, 7, and 9. So there's 5 of them. And if you just put a half because you knew that was the answer, that's fine for these more basic questions. Number 3. A marble is drawn from a bag containing 6 blue, 6 yellow, 9 white, and 11 green marbles. What is the probability of drawing a yellow marble? Go ahead. Usually with probability, or any of you taking stats next year, there's a lot of reading involved. If you are signed up for stats next year, you're going to have to read carefully, sometimes paragraphs. Not paragraphs here, but very important words like in the directions. Those are very important. Sometimes one word can change everything. Probability of drawing a yellow marble. So successful would be the yellow ones, 6 out of the total. 6 plus 6 plus 9 plus 11, 32. Let's say you're not sure how to simplify that. They're both divisible by 2. Maybe a bigger number, maybe not. Divide by 2, I get 3. Divide by 2, I get 16. Does that simplify further? No. Sometimes when I'm not sure, I just divide by 2 first and then divide by a bigger number when I'm done, if you're not sure if there's a bigger number. Probability of drawing a marble that is not green. If you would, for me, I want to kind of go over some notation. Write down probability not green before your answer. Sometimes that's written like this. If you ever see that, that means not. It might be written some other ways too. When we get to other lessons, sometimes it's expressed differently. Let's see if I can find any other ways I've seen. I think I've seen this. With like a little C up there, like the contrast or the opposite of. But we'll go over that. All right, so same idea. The total is still 32. The ones that are not green are 9, 6, and 6, 21. Those are not divisible by 2 or 3, so I think that's as simplified as it gets. One other thing on this one. One way that you might think to do this is also to do, write this down, please. For not green, write down 1 minus the probability of it being green. For this problem, it's so basic, you wouldn't do it this way, but there are some problems that you will come across where this is going to save you a lot of time. So the probability of it being green is 11 over 32. If you type in 1 minus 11 over 32, or 1 is 32 over 32, you get the same thing. You can always do this for when it says not. Like the probability that it's going to rain versus probability it's not going to rain. They're going to add up to 1 every time. All right. Flip the page. Odds. I know we've heard odds before. This is one of the most commonly used incorrect words. Like outside the math classroom, if I say, what's the odds that I flip a tail? People say 1 over 2, right? That's what you heard. That is not true. That's the probability, 1 over 2. Odds, very different. Odds in favor or odds against an event. When all outcomes are equally likely, the odds in favor of event A and the odds against event A are, so there's 2 different formulas. The odds in favor is the number of outcomes in A over number of outcomes not in A. We'll get to the odds against in just a second. So let's say the odds of rolling a 5. How many outcomes are there that are a 5? 1. How many outcomes on the dice are not a 5? 5. Probability is 1 over total. Odds is like wanted to unwanted. That's sometimes how we write it. Wanted, I want a 5 over not wanted. That's usually how we say it. So what are the odds of flipping a tail? What over what? 1 over? 1. 1 over 1. 1 is a head, a tail, and 1 is not a tail. Probability? 1 over 2. Odds of rolling a tail? 1 to 1. So it's most of the time when people say odds outside of the math classroom, they say it wrong, and they're actually talking about probability. Odds against is just the fraction flip. So you take the fraction and flip it. So number of outcomes not in A over the outcomes in A, or not wanted over wanted. Let me give you another quick example. Odds of drawing an ace. How many are aces? 4. How many are not aces? 48. And we would simplify that. If I said, that's odds in favor. If I said odds against an ace, it's just simply the fraction flip. Don't worry too much about it. It's just a little word, either odds or odds against. All right, here's some examples. Example 4, a standard 6-sided die is rolled. Have you guys seen dice that are not 6-sided? I've seen some 8 or 16. There's a lot out there. So if I ever don't say it's 6-sided, assume it's 6-sided because most of them are. So a standard 6-sided die is rolled. Find the odds in favor of rolling a 6. So that's rolling a 6, not a 6. If you wanted to show work and really get it clear in your head. You don't have to write it. You can just write the number. On the dice, how many are 6? Just 1. How many are not 6? 5. And you don't have to label it. Sometimes it's written like this, or a fraction, or sometimes like this. I don't care. It's all the same thing. 1:5, 125, or the fraction 1 over 5. Try the next one. Find the odds against rolling an odd number. So this is for finding the odds of rolling an odd number. If I want odds against, I flip the fraction. So out of the 6, how many are not odd? 3. How many are odd? 3. So 1 over 1 or 1. Pretty easy so far. Just a big difference between the word probability, wanted over total, odds, wanted over unwanted. Example 5, a marble is drawn from a bag containing 6 blue, 6 yellow, 9 white, 11 green. Find the odds in favor of drawing a yellow. When you're done with that, find the odds against drawing a white. first one, odds in favor of drawing a yellow. It's helpful for me to write yellow over not yellow so I don't accidentally do total. Yellow, there are 6 that are yellow and 26 that are not yellow. Divide by 2, 13. Odds against drawing a white. So normally it would be white to not white, but it says odds against, so I flip it. So how many are not white? Not white, not white, and not white. That makes 23. The white ones are 9. That does not simplify. Questions at all? Okay, experimental probability. We talked about this. I will read the paragraph. Experimental probability of an event. When an experiment is performed that consists of a certain number of trials, the experimental probability of event A is given by the number of trials where A occurs. Not how many times you think it will occur, how many times it actually occurs over the total. So number 6, exam grades of students in a history class are shown in the bar graph. Find the probability that a randomly chosen student in this history class received a C or better. Probability of a C or better is a C over, I guess that would be a C or a B or an A over the total. You don't have to write all this work. I could have gotten a C or I could have gotten something better, a B or an A over the total. So 8 people got a C. Better than that are 12 and 7. So 27 people got a C or better out of the total 31. Does that simplify? No. You won't get a calculator for this section on the quiz though. All right, your homework is right there. You can go ahead and get started.